Here is a video on vitamin C. So now we'll speak about the chemistry of vitamin C. The vitamin C is mainly derived from the ascorbic acid. The main sources of the vitamin C include the citrus fruits. Remember C as citrus, like the lemon, orange, mosambi, etc. The gooseberry, that is amla, is also a very good source of vitamin C. Guava is also a very good source of vitamin C. So these are some of the rich sources of vitamin C. Now we'll look after some good sources of vitamin C, that is green leafy vegetables, veggies, potatoes, tomatoes, etc. Now we'll look after the biochemical functions of the vitamin C. So the main function of vitamin C stands for collagen, remember. So it helps for the collagen formation. That is, the protocollagen is converted into collagen, that is from inactive form to active form in the presence of the hydrolase enzyme. Usually during the conversion of the inactive to active form, hydrolase enzyme is used in the presence of vitamin C. So the first function is it helps for the collagen formation. So the second function is it also helps in the synthesis of the norepinephrine. So it helps in the synthesis of norepinephrine, where the dopamine is getting converted into norepinephrine in the presence of dopamine beta hydroxylase and also the cuprous ion and vitamin C. So dopamine is getting converted into norepinephrine. The third one is bile acid synthesis. In the process of bile acid synthesis, the cholesterol is getting converted into 7-hydroxycholesterol, which is further getting converted into bile salts. So cholesterol is getting converted into 7-alpha hydroxycholesterol in the presence of 7-alpha hydroxylase and vitamin C, which finally gets converted into bile salt. It also helps in the synthesis of steroid hormones in the adrenaline cortex, also tyrosine metabolism, tryptophan metabolism. It also has the antioxidant property. It reduces the cataract formation in the eyes. The Keir-Fisher ring formation is also decreased when there is increase in vitamin concentration in our body. It also helps in the phagocytosis. Phagocytosis is nothing but killing of the foreign particles. When any foreign particles enters inside a body tries as much as possible to protect and to remove all the foreign bodies. So phagocytosis, stimulation of phagocytic action of the leukocytes and helps in the formation of antibodies. So the next one, role in iron absorption. It also helps in the absorption of iron. We know that iron is absorbed only in ferrous form. So the first thing is the ferric ion, that is Fe3+. Ferric ion should get converted into ferrous form, which is the absorbable form. This process takes place in the presence of vitamin C. So here also vitamin C plays a very important role. It also helps in the reconversion of methemoglobin to hemoglobin. It also helps in hemoglobin metabolism. How it is helping in hemoglobin metabolism? By converting the methemoglobin to hemoglobin and converting hemoglobin to methemoglobin. So the next function includes the beneficial effects on the common cold. So when there is common cold due to the rhinovirus or adenovirus, that time if you take some vitamin C tablets, it will decrease the duration. If it is some 5 days, it will decrease to some 3 days. So vitamin C also plays during the common cold condition. Next, we'll study about the deficiency. What happens if there is deficiency of vitamin C in our body? When there is deficiency of vitamin C in our body, we can see scurvy. So what is scurvy basically? It is bleeding gums. Infantile scurvy is also called as Barlow's disease. Scurvy is mainly caused due to defective collagen synthesis. You can see there will be bleeding gums. It is mainly due to defective collagen synthesis. There is decrease in collagen synthesis in human body. We look after the characteristics of the vitamin C. Sore oral cavity, spongy, swollen bleeding gums. You can see there will be swollen bleeding gums and it is very, very painful. There will be loose, painful teeth. Also, internal hemorrhage can be seen. In severe cases, hemorrhage occurs. Conjunctiva, retina and internal bleeding can also be seen. In bones, how does vitamin C affect for bones? It also causes bone fragile, weak bones and easy fractures. These are some of the deficiency if there is decrease in vitamin C concentration. In nails, what you can see, spoon shaped nails, concave nails, thin, brittle. Your nails will start to become brittle. You can see there will be red spots on the nail beds. You can see there is presence of red spots on the nail beds. So these are some of the important characteristic of the vitamin C deficiency. Also causes anemia. There is decrease in RBC count in our body, mainly microcytic anemia. You can also see weakness, muscle ache, delayed wound healing. So there will be delay, clotting time, bleeding time, etc. So what is the therapeutic use? What medications you have to give? You have to treat the infection as fast as possible. Heal the wounds. When there is ulcer, wound, burns, trauma, you have to heal this by giving some proper medications to it. You have to increase the vitamin C tablets consumption. So toxicity, it can cause Fe overloaded as it helps in the absorption of iron. So in this case, what is happening in the sense, the Fe3 plus cannot be absorbed, in the sense it is not in the absorbable form. So Fe3 plus has to get converted into Fe2 plus. When the Fe3 plus concentration starts to increase, obviously the Fe2 plus concentration also starts to increase. Fe3 plus is getting converted into Fe2 plus in the presence of vitamin C. So gradually when this process is increasing, the vitamin C concentration also starts to increase and literally it causes toxicity. There will be over concentration of vitamin C in our body. So that's it about this video. I hope you have liked this video. So please do like, comment, share and subscribe. Thank you.